just, yes. At first, a small preface. Two things inspired me for this talk. First, it is a detection of a dust trail in space. I waited for this very long time, many years, because one thing observed, it is ground-based observations, and another thing, it is something far from the Earth. And what this instrument found, is it a trail Geminid core, and what it is a Geminid core anyway. And I hope that very soon we could submit this paper, which is now under preparation. And working on this paper, I found a thing that I'm going to talk about now. And the second is paper Haidukova with colleagues, and they comparing for data set and found that a trend between radiant position and semi-major axis of meteors. And this is a topic I am going to talk at the end. And just to remind you that the Geminid meteoroid stream has very eccentric orbit, and it is situated far inside Jupiter, just about that. So I compared numerical model, just two meteoroid masses, and Czech video observations published by Koten and colleagues, and published by Boroviʼcka and colleagues, and only records of a good quality. And as you see, Czech video observations have, Czech video observations have neighboring intervals from 10⁻⁴ degree gram, like this. And these bolides, large ones, well, represented more or less by this. Here you see how nodes are located along the Earth's path. This solar longitude, and you see that in principle observed, yes, observations were in maximum, and model is a complete activity period model. So you see it is a shift which I already noted in previous papers, because I think that Geminids were ejected not from the current phaeton orbit, but from pre-phaeton orbit, which was another one. It's probably a larger semi-major axis. And now let us see the same, but in phaeton-centered coordinate system, just cross-section normal to phaeton orbit plane. And here you see such cross-section of two samples of observed meteor orbits. It is, you see, smaller one and larger one, bolides, and two samples of model orbits. Theoretically, because of Poynting-Robertson effect, smaller meteoroids should be more or less closer to the sun. But in principle, we don't see this even in model meteoroids. And in observed orbits, well, we don't see this shift also. It is interesting question. Why? Now let us see this one. This is only model cross sections, shower and streams, and this is stream. This is also stream and shower, model shower, this one. You see that shower is situated below phaeton orbit and at the more or less at the outer part of phaeton orbit, this phaeton orbit. And the maximal density of meteoroids is far from the Earth. So you see what definitely it is model. Model could be fitted by observations, but we have no data enough for that. Nevertheless, model is a good thing to understand what could happen, namely that shower probably not quite representative for the stream. Yes, sorry. Why this stream has such shape? Strange, yes. Because of this, because space shape of the Geminids has very interesting shape. At this, the very, very first 3D model made at the time when we have no yet computer things like Photoshop and so on. It was just made by airbrush. And this is a place where the Earth intersects the stream. And this, the most dense place goes like this. And summary for the first part, that meteoroids of a shower may be not representative for a stream. And now several words about future work. Haidukova with colleagues found trend, as I already mentioned, trend that smaller semi-major axes are, it is radians, smaller semi-major axes are at the west part of the radiant and like this. Later, I found in my semi-analytical model, it is, I forgot to mention that this is about 10 minus 3 degree gram, but it is not the same. You see, here, shorter, smaller semi-major axes are here. Here, not like this, but like this, something else. Okay, it was, I reported this in online seminar for a narrow circle of colleagues. And now this is Boroviʼcka and Spurn published. I think that it is more precise picture and semi-major axis from this shorter to this longer, like diagonal. And this picture I made yesterday, from shorter to longer. How do you think? Is it looks similar, isn't it? And certainly it is interesting to find out the reason. I only began this study, and it is definite that semi-major axis value of semi-major axis should somehow be related to velocity of ejection and other things. This is a true anomaly of ejection. I like this picture. But they are similar but not identical. And I think it is worth to digging further into this subject. And I'm going to do this rest of year and maybe next year. So that is all I wanted to say today. Please, questions.
All right, thanks, Galina. Do we have any questions from the room? I guess I've got one that is probably maybe a bit more of a general question, but do we know how much denser like the Geminids stream is like in its core compared to what we see at Earth? Like, we know roughly what that factor might be?
Do you mean dense in what relation? Dense in a physical sense, or I mean density of meteoroids or density like flux?
So density of meteoroids. So if the Earth was somewhere else, like could we get to
there are very various opinions of colleagues. I collect my model for 1 gram per centimeter cube. People prefer something much more dense, but why I do so? Because many years ago, I consulted with Bronsted. Maybe you know this name. It is physicist, very famous physicist, and he said not more than 2. But this model could be easily calculated for any density. For definitely for spheres.
All right, thank you. Any other question for Galina? Got one for Ishi.
Galina, you asked at the beginning if the photon trail observed in space is core of the Geminid stream or not. So,
yes.
What's your opinion about that?
It is difficult. At first, we had to submit this paper in February, but situation is look like that. We can't answer this question. Now we think that it is probably yes. What this whisper instruments see, it is the most dense, not core, it is the most dense, how to say it, filament, the most dense part. But another thing, what masses of meteoroids, I think 10⁻⁵ degree grams, or 10⁻⁶, but 10⁻⁵ preferable. They are dominating. All this will be in this paper.
All right, let's thank Galina again.